What we're going to do today, as you know, is the introductory session. By the way, I'm Jay Icut, and the person you saw before me in front of the camera talking with you was Alden. She's been the one emailing all of you guys and setting things up. So we'll start off with, I'll do a short presentation. It should take about 20 minutes. Just telling you what GENI is and you know, what you can do in terms of using GENI in your classroom, and then we'll go on and do a hands-on exercise, which we call Lab 0. It's really basic intro to GENI, your first exercise on GENI. That would be the entire webinar today. And then for those who've signed up for next week, that will go into more details exactly on how you use GENI in the classroom, not just in terms of you know, what resources are available to you, but also to help you plan, to let you know how you should think about this, and when you should start planning, who you need to contact, and so forth. But that part will be next week. So like I said, we'll go over what is GENI, how is GENI being used, give you an experimenter's view of GENI and its resources, talk a little bit about upcoming GENI events so that you know how you can get plugged in, and then finally we'll get into the hands-on intro to GENI exercise. So GENI is a large-scale network used as a test bed, and what this allows us to do is, currently we really don't understand, we can't predict the behavior of large complex networks, and GENI allows us to experiment and create the right new protocols, think about, you know, next generation internet using current resources. So what you can do with GENI is run very large at-scale experiments, and it's deeply programmable, and I'll talk to you in a few slides what we mean by that. And of course, there are lots of other issues with all of us, you know, having connectivity everywhere with Internet of Things. You can imagine the amount of explosion of data and what we can do when we have at-scale experimentation available to us. So think of GENI as a lab for novel networking research. And what you see here is a map of the US showing regional networks that are both existing ones and new ones. This is the map itself is sort of old, so most of the ones that say new have been around for a bit. There's GENI WiMAX, the triangles that you see, lots of GENI racks, and GENI racks could be a couple of racks of GENI equipment, and it could be hundreds of equipment as well, depends on how large that site is. And then all of this is connected by an Internet to an NLR backbone. So what you have here on this slide on the right shows you more, gives you more of a picture of those network resources. You have access to programmable switches and layer 2 VLANs. So you have lots of rack switches, and this is what we mean by deeply programmable. You don't just have access to computers where you can install your own software, but you can also program the switches and have access and run your own new protocols and so forth. So really, you have complete control once you have created your own experimental slice in GENI, and we'll talk about what we mean by your own controlled slice. But as I said, Internet 2 research backbone is available to GENI. And then on the left, you see the compute resources. So you could have access to virtual machines. You could have access to entire bare metal machines. You also have WiMAX, a lot of Wi-Fi capability where you can have access to programmable handheld devices. And then if you are familiar with the old EmuLab and PlanetLab networks, they're all now part of GENI. So here, this gives you a more realistic current picture of GENI's footprint today. And as you'll see from the legend, there are entire campus networks connected. On the West Coast, you can see Stanford. There's if you go towards the Northeast, you'll see UMass, Michigan, and then in the middle of the map, there's Colorado. So there's entire campus networks, but then all over the country, and of course it's more concentrated in certain areas, but there's WiMAX LTE, advanced layer 2 service, and then you see the IG ones are InstaGenie racks and EG are ExoGenie racks. And the only reason you don't have to worry about what exactly they are right now, the only reason I'm pointing them out right now is when you run your experiments, we will ask you to pick any InstaGenie racks. And so that's what you'll be looking for. For example, there'll be a Clemson InstaGenie rack, and you can access that, or a UMKC InstaGenie rack. So you can have multiple GENI experiments running on the GENI resources concurrently. And how that is done is by what you see there are the dots connected by the lines are GENI resources in various geographic locations. And each of those geographic locations or site is what we call an aggregate in GENI. So you're picking resources from different aggregates and you're creating your own GENI network, and that piece is called your slice. So an experiment lives within a slice. Okay, so back to this. What you're seeing there are two separate experiments. So they're two separate slices, but like I was saying, those vertical lines sometimes are sharing the same resource, but not exactly the same virtual machine or the virtual resource on that particular machine. So you could be sharing the same machine, but in completely different experiments. And the cartoons you see on the right there are have been used for illustrating GENI users for a very long time. So what happens? You create your own experiment. You can install software throughout your network slice, not just on the virtual machines. You can program routers, switches, all of it. So again, back to the deeply programmable, that's what that is. And you can think of GENI as an edge computing platform. Basically, as you know, with edge computing, you're talking about being able to perform data processing at the edge of the network, creating less traffic. GENI, in that sense, is a nationwide edge cloud. And what you see here are all these racks all across the US. Again, showing you a diagram I had shown earlier, except in the form of having racks all over the US. The GENI edge clouds are now connected to CloudLab and AWS. CloudLab is one of two very large, also NSF funded. So GENI itself is funded by the National Science Foundation. It has been for about 10 years now, and it has really grown over these 10 years and continues to expand. But the NSF also has more recently funded two, two similar networks, CloudLab and Chameleon. And CloudLab is more closely connected to GENI. So you'll find that if you have an experiment on GENI, you're also able to use resources from CloudLab and Amazon AWS. So this was just a quick overview of what exactly GENI is, what do you have access to. So how is GENI being used currently? GENI has been used for research as well as education. It started out with being used for research more so than education at first. But I can tell you I've been more involved in the education piece of it, and there are several folks that not only, and we'll give you numbers, not only teach using GENI in the classroom, but also provide resources that you can use if you don't want to develop them yourselves. So this is just to give you an idea of all the different areas in which GENI has been used in research as well as education. Besides the usual, university research and education, there's been GENI used in K through 12, graduate and undergraduate. In fact, the piece that you see, grad, undergrad, I believe is a classroom in Greece. So GENI has users internationally as well, and collaborators with the similar network in Europe. And this is just to tell you how, and these are just projects done by folks all across GENI. So this one was students at high school in Colorado learning math and programming using the Mars rover. They developed a game using GENI and got kids interested in that. These are other examples just to show you the reach of GENI basically here. There are currently over 4,500 students who have used GENI in classes taught by 73 instructors. Last semester, which is spring alone, we had 24 classes with 638 students using GENI. Now, I will tell you, even as I'm giving you all these details, that GENI is, after all, an experimental network. So it will not always be 100% reliable. Things do break. And it's better that you know that up front and tell your students as you give them access to GENI resources and have them run experiments there. And the beauty of it is if the students make a mistake or anything happens, you can always have them just delete their resources and start anew, which is not possible with machines that you have in your lab as easily. This leads me to talk about, why use GENI for education. First of all, many years ago, I used to maintain a lab down here at UNC Chapel Hill. Our networking lab had hundreds of machines. Well, hundreds is an exaggeration, if you count virtual resources, but there were 150 machines in the lab that we would build multiple networks of that. One network alone that I had about 60 some machines, but every time one machine broke, I had to go fix it before I could do anything else. In this case, you have access to all this expensive lab equipment across, 24/7 access across the US, so you don't have to maintain it. It also allows for lots of sharing of resources in terms of teaching itself, because there are some of us who've actually been funded by NSF to create modules to teach networking, distributed systems, and security, other courses, course modules, and we make it available to anyone to use. And I can show you those resources, I think either at the end of today's or definitely next week. And if you develop a module in the process of using GENI in your classroom, I would encourage you to share that as well. And we have a system now where it can be much more easily shared. And of course, it allows students to learn by doing. And they can mess things up and you don't have to worry about it because you can easily reconfigure a resource. Talking about folks who have done a lot of these GENI in education resource building, there's Mike Zink in UMass Amherst. Then there's us at UNC Chapel Hill, and we have a lot of GENI modules. And the way we, sorry, that was, we're in a conference room where if you don't move for a while, it starts shutting things down. The way we built our modules here was to look at how undergraduate networking is taught in a course, and take specific concepts. For example, TCP, UDP, how two TCP flows behave with each other, fairness, and so forth, and develop modules that specifically show how to run an experiment, and and we've actually created videos of us running the experiment and explaining it, so that you could either simply use the video in your classroom as an added aid in teaching that particular concept in your class, or you could do that and then go further, which is to have the students themselves run experiments and report back. Or the third idea is to give assignments based on that module, and have students run experiments outside of class. And people have done all of that and used our modules extensively. And the third one is in NYU Poly, where they've actually built a MOOC on GENI, among a lot of other things that they've done using GENI for education. The MOOC is very popular as well. GENI course modules, there's a lot out there now, and we actually maintain a GENI-based classroom exercises list. So this is the one when I said earlier, if you develop something and you'd like us to share it with everyone, you can send it to us and we'll upload it on our site. And all of this, even when you see the slides later, if it's not clear where exactly to get the resource, just send us a note and we'll be happy to point you in the right direction. So one of this is the GENI in the Classroom webinar that you're at. It's offered start of every semester. This semester there's a little bit of a delay. It's not quite the start for some of us. It used to be called Teach the TA, and then we had a lot of faculty very interested, and so we're not calling it GENI in the Classroom. It's 2 sessions. This is the Intro to GENI, and next week we'll talk more about actually setting up your class for using GENI in your classroom. So in terms of GENI terms and definitions, we did talk about SLICE quite some, using the same picture that you see. An experiment uses resources in a slice. So whenever you think of a slice, it's your particular experiment. And each slice is isolated within the GENI infrastructure. So even if you create 2 slices using resources in the same aggregates, they're still separate experiments. And if you create a slice, which is usually created within the context of a project, you are responsible for your slice. So here's what this looks like. So what you're seeing, the two pictures, on the left is a project for a research set of experiments, and the one on the right is for a classroom. So in terms of setting it up with people involved, think of it as the researcher or the professor being the project lead. And when you create a project as the lead, you're the owner of that project. You can have several members of the project. So for example, in the research project, you can have your research assistant or your postdoc as members. And for the teaching, for the classroom, again, you'll be the lead. You can have your teaching assistant as the project admin, not just as a member, so that the teaching assistant can pretty much do all of the things that you can do as project lead. And so they can manage your students who would be project members. And we'll go into more detail about actually managing your GENI resources and how you set things up next week. So projects basically organize your work on GENI, whether it's research or teaching. And every slice created by the members are created within the context of that project. Only project leads can create projects, so you can't have your research assistant create a project because there's some check on project leads being either faculty or researchers who are allowed to create projects. And then leads can invite anyone. And just to give you that context, you all are members of the project that you joined, which was the Classroom Fall 2017. I'm the project lead on that. Alden's an admin on that, so she can do pretty much anything on that project. There's a Clearinghouse and Aggregates, and Clearinghouse basically manages all of this. The users, projects, slices, everything. And Aggregate is what you can think of it as a site. An aggregate is any organization that owns some resources within GENI, and it's usually a geographical location. We talked about an aggregate, we talked about a slice. There's the other thing that you'll hear often, which is a sliver. Now, remember those pictures of that green slice and the red slice, and each of the slices had resources from different aggregates. So the resources that were at one aggregate are called a sliver. So in that sense, a slice can contain many slivers from several different aggregates. And another thing that you'll come across is called RSpecs. RSpecs is basically just, we'll show you how to run an experiment. And before you do that, as part of the setup of the experiment, you're just going to create a client server, a simple topology there. And it's all done using tools, so it's really simple. But if you want to go look at the language behind that, you can see the RSpecs. I can assure you that you can run complicated experiments on GENI without having to sit and deal with the RSpecs, but you're welcome to do that if you want. So reserving resources, basically, you have these experimenter tools, and the RSpecs are used on the back end to talk to the aggregates. So what happens is you say that you want a VM in a particular aggregate. The RSpec is set up so on the back end, there's a query to the aggregate to figure out whether that resource is available before it is released to your particular slice. So that's where you have the aggregate manager come into play. So asking what you have, an advertisement as RSpec responds with what the resources are available, and then there's a request RSpec to create that particular sliver at that aggregate, and then the allocation is made. So the hands-on lab 0 that we're going to do today is very simple. We're going to have 2 virtual machines, one a client, one a server, connected. Okay. So we create a slice, and you can have a slice as simple as this client server or as complicated as you wish. And then you create resources at one aggregate. So we're going to keep it very simple for today. And then we'll generate some mild traffic using ping and iperf that everybody is probably familiar with. And then we'll show you how to delete the resources. Before we jump in to the specific lab, I just wanted to tell you about a few upcoming GENI events. And again, all of this is going to be up on our site. We'll send you email after this session's over sometime in the next day or so. The GENI Nice is sort of a community gathering. It's held in conjunction with ICNP this year in Toronto. It's coming up very soon. There are a series of regional workshops that have been held last year and this year, and I think it's going into next year as well. And the next one is at University of Oregon. There's also a CNERT workshop. It's specifically based on testbed research. It's in April in conjunction with Infocom. So if you're headed there, you should definitely check out CNERT. And then there's, this thing is new, an experimenter contest. We've had some in the past, but this flavor is new. And I've included the link to that so that you can go check it out later. So that's pretty much it for a really quick, very high level, 10,000 foot view of what is GENI and what is it used for. Yeah, I will say that there's a lot of resources. There's a community where you can ask questions. So make sure, in fact, I think I have that at the bottom of this one. It says subscribe to the GENI announce mailing list. There's a GENI educators mailing list. So if you get on the right mailing lists and ask questions, you can learn even more about GENI. And of course, you have all these events where you can connect with others using GENI. Let's go ahead and hand this over to Alden now, who will run the lab for you.
Hi, everyone. I'm Alden, and we're going to be running the Lab 0. So I'm going to be running through the lab in live time, and then also hopefully you'll be running through it with me. So if you have any questions at any point, you can put them in the chat or unmute yourself and let me know. So I emailed out the lab instructions, so you should have the worksheet that looks like this, and the instructions that look like this. And then also all of that is linked on the wiki page for this session down here. So if you're missing any of those, and then the slides I'm going to be using are there as well. Okay, great. So again, here's the link if you don't have the instruction set and worksheet in front of you. They're helpful. So yeah, our simple experiment, we're just going to be reserving 2 virtual machines and connecting them, and then doing some stuff with ping and iperf. So in GENI, we have a 3-part experiment workflow. So the first part is designing and then setting up your resources. The second part is we're calling execute. So this is where we're going to be running the commands and such, and doing the actual experiment work. And then part 3, finish, is where we're collecting our data and then deleting our resources so that other people are able to use them. So we have 3 overall goals in this experiment. First, we want to run through a full GENI experiment. Second, we want to talk about or use some of the terms that we just saw in the previous presentation, like experimenter, project, slice, resource, and aggregate. And then third, we want to use GENI tools like the experimenter portal and JAX, which is a way to reserve resources, to get familiar with those. So we're going to start in the first section. And so the experiment's already designed for us. You need to create a GENI account, which it looks like most people have done, and then join the Classroom Fall 2017 project. And then our first live part is we're going to generate and download an SSH key pair. So if everyone wants to go over to the GENI portal and go ahead and log in. GENI portal, that's just portal.geni.net. And then go through the login screen. So up here I have, let's see. When you get in home, it might give you slices or projects. So you want to check out our class fall project, and it looks like somebody asked to join, which is good. I'm going to go ahead and do that. So yeah, like we were saying earlier, we have a lead, I'm an admin, and then everyone else on this is a project member. So hopefully everyone has gotten logged on to GENI and they're part of the project. If you're not part of the project, go ahead and search project and I'll add you really quickly. But otherwise, we're going to go ahead and generate our own SSH key pairs. The one I sent out in the email was specific, was a test one, but you want to have your own. So if you navigate over to your name, if we can see, and then go to, go to SSH keys. I've already downloaded one, but your screen, if you haven't downloaded one already, should give you an option to generate a key. So if everyone wants to go ahead and do that, that would be great. Okay, so then yeah, once you've got your key ready, then you need to download the private key. So if you're using PuTTY on Windows, download the PuTTY key. If you're on Mac or Linux, just download the regular private key. So go ahead and download that and make sure you know where it is. And then if you're on Mac or Linux, so on whatever machine you're using that's not Windows PuTTY, so Windows PuTTY has a different format. But if you did the pre-work with the SSH, you should be familiar with that, hopefully. So if you're on Mac or Linux, you need to go ahead and move the key to your SSH directory and then give it the correct permissions and then add it to your authentication agent. And then once again, it was download this key for Mac, Linux, and download the PuTTY key if you're using PuTTY on Windows. And yes, thank you. Remember to save and remember your passphrase because you'll need it every time you need to log in. Okay, yeah, so if you are on the portal page, just to go back over this, however you logged in, then you want to go over to your name and then it's in the upper right hand of the screen and then down to SSH keys. And in that area, it should give you an option to generate a key. I've already generated one, so it's not showing up on my screen, but you should have a generate and download. And then once again, if you're on Mac or Linux, you want to download private key. If you're on Windows and using PuTTY, you want to download the PuTTY key. If you're on Windows and using Fire SSH, you want to use the private key. If you're using anything but PuTTY, use this private key. If you're on PuTTY, then download the PuTTY key. And then, yeah, if you're on Mac or Linux, you need to make sure you execute these commands to make sure that your key's ready. If you're using Windows, you're just going to select it from whatever directory you're in PuTTY later. So just make sure you know where it is. Okay, so we're going to go ahead and move ahead into the next part. So if you're following along in your instruction set, we're on step 3 now. So in this step, we're going to create a slice. We're going to look at how you can renew the slice if you'd like to, and then we're going to reserve 2 virtual machines at an aggregate, and then we're going to wait for them to get ready to be used. So back over in the GENI portal, if into projects. Looks like some people are here already. And then navigate into our Classroom Fall 2017 project. Great, so some people have made slices, but what you want to do is go up here and create slice. And then within a project, slice names need to be unique. So I'm going to name mine with my username and then lab0 because that's what we're doing. You do need to have a slice name. I'm going to leave the description empty and then create slice. And so that's going to open up Jack's for me. So it's going to tell me Jack's initialized, no resources yet. So let's just see, we have 7 slices in our project. Okay, so looks like everyone's making slices. If you're having any issues with that, again, let us know. But then within Jack's here, we want to go ahead and add resources. So go ahead and click on that, and it's going to open the editor. And your screen should look like this. Again, from that page, we clicked Add Resources, and now we're in the Jack's editor. And so what this is going to do is it gives us an interface to reserve resources so we don't have to use the RSpec. On this experiment, we want to use 2 virtual machines. So we're going to be using this VM right here. And like it says, we're just going to drag it over. So go ahead and grab 2 and drag them onto your screen. And then we want to name them client and server. So simply we're just going to click on the node, and then under name, we can change one of them to client, and then the other one to server. Then we want to connect these. And so the way we want to do that is highlight one of the nodes, and then when you go off it, you're going to get this black line. When you see the black line, you want to click down and drag it over to the other node. And so then you should have 2 connected nodes, one named client and one named server. Right, so how to change the names. So we click, someone asked in chat, we're going to click on the node, just select it, and then you should get this editor over on the left side. And in name, you can just change it, just type it in, and then click off and it should save. And then the same thing with server, just select the node and then you can change the name field over on the left. Let's see, selection of a node isn't working. Yeah, so if it's not working, you can go up here and delete all. And then that's gonna start over, and then you can try it again. So I'm gonna walk through the steps one more time quickly because I just deleted mine. So then hopefully once you've deleted them, it'll be working for you, and you start over. Okay, so then we wanna do is assign IP addresses to these interfaces. So to do that, we wanna select the connection node or link. And then if we're looking at this interface, it lets us pick an IP address. It lets us name it. We can pick a net mask. And the same thing here, this is our interface to server where we can pick an IP address and a net mask. So you can either do that manually, or what's nice and easy is to scroll down under editor ops here, editor operations, and you can click auto IP and it will do it for us. So then if we go back up and we can click on the link again to check, it's given us IP addresses. For me, my client was 10.10.1.1 with a corresponding net mask, and it gave the interface to my server 10.10.1.2 with a corresponding net mask. So go ahead and add your IP addresses to the interface. And then auto IP again was if you scroll down next to editor ops, there's auto IP. Then once you've done that, select Site 1 by clicking on it, and then this is where we're going to pick an aggregate. So you can check this scroll down menu for site. Like we said earlier, we want to be using InstaGenie sites. So the ones that are InstaGenie are labeled, so Case Western InstaGenie or Clemson InstaGenie, any of these. As a note, when you're selecting sites, if everything's up and working well, it's going to give you this site is up. If there's an issue, it's going to give you this red, I guess, octagon. So just pick one that is up and that is InstaGenie. So you can go ahead and select one. And then it's going to change your site name so you know what it is. You can select a different one than I did. So once you have your site selected, then we're going to go ahead and reserve our resources. So down at the bottom, you can click Reserve Resources, and it's going to work with the site to start reserving those virtual machines we wanted. And so then we're going to get progress details. Yeah, so this first step, it's going to just start requesting the resources. This can take a minute or two, and then it's going to tell you it's finished. But the resources aren't ready for use yet. This just means that the RSpec is through. So what we have here, this is some login information. We can get this again later, but we are going to be using this. So for my first node, it's giving me my SSH information, and also for my second node. And then you might want to keep this page up because the information is really easy to get here, but we can also find it later on the slice page, which I'm going to navigate to. So from this page, going to the slice page. And this is where we're going to know when the resources are ready. So they're not green, which means they're not ready. And it's just going to keep pulling until they're ready. So this can take, it usually takes about 5 minutes for something small like this, but depending on what's going on, it can take 20 to 30 minutes. So hopefully we're only going to be about 5 minutes here. So that is one thing in chat. Also, if you're not at this stage, let us know, but then once your resources are ready, go ahead and let us know that as well. And then if you're at this stage and you're waiting and you have the SSH information here, then that's something you can go ahead and fill in on your worksheet, because we're going to use that to connect. So in your worksheet, which I've brought up just now, we have our login to nodes. So client login, and it's going to give, this is your username. So for me, this is Alden C, and then at whatever the aggregate name is. So for me, I would be at pc1.instagenie.louisiana.edu for my client, and then the same for my server. The port number here, you are going to have a different port for your client and your server, so make sure you get those two different numbers and fill them in as well. And then once again, that's from this page here. And it looks like my resources are ready, which was really quick. And so then from this page, I can also get the SSH information by clicking on the node, and it will let me know the same thing here with the username and the aggregate and my port number. Great, and then while we're waiting, if you aren't doing anything, we can look at how you renew. So on the slice page, it's just simply up here. You click renew, and then you can choose whether you just want to renew the slice or the slice and the resources. So if you renew the slice and the resources, that would include the nodes you'd reserved, and then you can pick what date you'd like them to do and then renew them for longer. So this is, the slice is in 6 days, so that's not, we're not gonna need that for any more time, so I'm not gonna renew. But if you have a project that's ongoing and you wanna keep your slice and your resources, make sure you renew, or it will, or you'll lose what was, in it.
So while we're waiting for everyone to have their resources ready, I just wanted to point out that as the project lead, if you're the professor, or as the admin for the project, if you're the TA, you will have access to all of the student slices. which is great because if a student emails you saying they have a particular problem, you will be able to log in to their slides and figure out what's going on. And similarly, the student can't just keep their slices forever. You can delete slices once the class is done, or if you want to let go of resources, you have access to their slices completely. That's just something that will save you a lot of trouble once you have your students setting up their own slices. Just wanted to put that in.
Okay, great. So we're going to move into the execute stage of the experiment now. Okay, so in our execute stage, we're first going to log into both of our nodes, and then we're going to, for our experiment, we're going to just first test the connectivity between them, and then we're going to look at difference in the data in the control planes, and then finally we're going to log out. So the SSH here should work the same as it did in the pre-work test that you did, except of course you're going to be using the SSH key that you generated earlier, as well as the login information from the specific nodes you have. So just to review from what you had earlier, and then also the instructions are in your in the instruction set. If you're on Mac or Linux, you just want to enter into the terminal this command I put in. This is an example from one I had done earlier. Fire SSH, I don't know if anyone's using in Firefox, but this is how you would do it in the search bar. And then PuTTY, you need to fill in the host field, the port field, and then give it your key location under connection type. So you want to go ahead and log into both nodes with the SSH information that we got from here. I'm on Windows, so I'm going to be using PuTTY. So I'm going to go ahead and go for that. I think, yeah, so I'm going to do the PuTTY version. Hopefully type this correctly. And then I'm just giving it my specifically PuTTY key. And so let's see, my client is up. So this is what it looks like once you've logged in. I have my GENI username at client node. So then once you've done that, go ahead and log into the server node as well. And then I've also logged into the server node. So you should now have two nodes up, your client and your server, and be logged in. And so again, this is the same procedure that you did when in the pre-work. Here again is our cheat sheet for logging in depending on where you are. It's going to ask you for your passphrase. That's the passphrase that you made in when you downloaded the key. If you're ever at a point where it's asking for a password, something's gone wrong. So the GENI resources all use this public-private key setup. So if it's asking you for a password, there's a mistake somewhere. I think in PuTTY, if you forget to upload your key, it asks you for a password, so you know then that you need to start over and give it your key. I'm not sure where else. But it is going to ask you for the passphrase, but if it needs a password, then there's an issue. And then the detailed instructions, again, if you're having any trouble, are in that instruction sheet. We're on part 4, the logging in. And it gives specifically in detail if you're on Mac, Linux versus Windows PuTTY. All right, terrific. It looks like people are logged in. So then the next step is we're going to run ifconfig in both of our nodes and get the information, like the IP addresses for the various interfaces that we're going to need to ping with in a minute. So in your window, you need to run sudo, so you have permission, and then ifconfig. Then it's going to give you some information. And so you should have a data link up. So for me, this is my ETH1 right here. I know it's the data link because it has the address that I put in, or that I had the auto IP put in earlier when we were making the nodes. And then this is my control interface. So what you need to do on your worksheet, because we're going to be pinging to these in just a minute, is go ahead and write down both the IP addresses for your control interface and for your data interface, and then the interface name, so ETH0 and ETH1. On your worksheet, it might have a number already filled in for your data link that might be incorrect, so just go ahead and fix that. It looks like it's 10.1.1.1, but on mine it's 10.10.1.1. So make sure you have the correct addresses so that you're able to ping. You need to go ahead and do the same thing on the server node so that we have all of the information. And then you're filling this in on your worksheet, if that's helpful, in the worksheet down here. So for me, this was ETH0, and then my IP address was 172.17.1.1. And then down here, this was ETH1. My address was 10.10.1.1. So everyone go ahead and get that information down. And then we're going to start pinging. Okay, great. Once you have your addresses all filled in, we're going to start pinging. So first, just to make sure the connection's there. So from your client side, just ping and then put in the address of your server data IP address. So mine was 10.10.1.2. Yours is probably similar. If you did auto IP, if you did your own, then it could be different. And then you should be connected there. If you're having any trouble with that, let us know. And then after that, we're going to ping the control IP address, which you'll have a different number here, whatever you just found using ifconfig. And then again, your ping should go through and you should be connected. So I'm going to go ahead and do that on my screen. So first, I'm going to be pinging the data interface. And like we expected, that succeeds. And then I'm going to do the same thing with the control interface, which had a different IP address. And so again, my connection there succeeded. If your pings aren't connecting, if you're losing packets or anything, that's not good. Let us know. You have the wrong IP address, so go back and check ifconfig to make sure that it's correct. Otherwise, if everyone is connected and pinging, then we're going to move on to the next step of the experiment, which is going to be using iPerf. So if you're following along the instructions, we're on 5.2. So the first thing you need to do is on both of your nodes, run this command to make sure that iPerf is installed. It's installed on all of the ones I've used already, so it should be pretty quick. So make sure that it is installed on both, which I'm going to go ahead and do here. So yeah, on this one, it was already the newest version. And then just make sure it's there. And then do the same thing on your server node. And once you're sure that it's installed, then we're going to start an iPerf server on your server node. And so that's just simply iPerf and then -S for server. So you want to start that up. And then over on our client side, we're going to start pinging first the data interface and then the server interface. And then from the client, you're just iperf-c for client, and then the IP address of the data interface for the server, and then the IP address, the control interface for the server. So I'm going to go ahead and execute those commands. So this is setting up a server, and so it's telling me it's working. And then over on my client side, sure, yes. First, I want to go to the data address or the data interface, and then run that. And so this is going to let us know also, once it's done running, the bandwidth of each of these connections. So from the data interface, what kind of bandwidth did people get on the data link? If you want to stick it in chat. And then also what for the control link. It's going to be telling you this bandwidth here. So mine, for my data link, was about 100 megabits per second. And then if I want to do, yep, okay. So everyone's getting the same for data. Let's see what I end up getting for the control interface. Okay, great. Looks like everyone's getting similar things. All right, I had, my bandwidth on my control was only 3.25 gigabits, but it should be much bigger than the data link, which it looks like everyone else is getting as well. And so a lot of the modules are set up like this, where they have built-in questions for students as they go along in the experiment. And so for our data link, we're getting just our standard bandwidth. And then on the control, it's that we're getting, of course, all of the bandwidth that exists. So then if you want to go ahead and jump into the next part, you need to shut down your iperf server. So just Command C, so that we can do a different experiment. So now we're going to jump into section 5.3 on the instructions, if you're following along there. And what that is, let's see, no one's on ExaGenie, so we don't need to do this step because everyone should pick an InstaGenie. So what we're going to do is start pinging from the client side to the server side using the server data IP address. And then over on the server side, after we've started pinging, we're going to bring down the data interface and see what happens. And so to bring down the interface, you need the interface name, which we found with ifconfig. You need to make sure that you have the right name, because if you bring down the control interface, then your whole experiment's going to lag, and you're not going to be able to do the rest of it. So over on my client, I'm going to start pinging, and this time I'm not going to stop. I'm going to keep the pinging going. So I'm not going to do the -C5 to only ping 5 times. So that's working. And then over in the server, I'm going to bring down the data interface. So that's ETH1 for me, and then bring it down. And then if I go back over to my client, I can see that the pinging stopped. And then when I come out of it, I can see that some of the packets, I lost packets. Yeah, so when we just brought down, we brought down the data interface, and our destination became unreachable, which we saw with the pings dropping. And so the why, of course, is that we brought down the interface, so there was nothing there to ping to. And then our last experiment, we're going to be bringing down the control interface on the server side. So on your client side, start pinging the server control IP address, and then over on the server side, bring down whatever your interface is named, it's probably this ETH0. But you can check from what we got earlier. So yeah, over on my client side, I'm going to start pinging to that control interface address, which is working, until I come over and bring it down. And of course, back on my client, it's telling me destination host is unreachable because we brought that interface down. And then over on my server side, I can't do anything because we killed the connection to the server. So that was our experiment. So we're finishing up part 5, and now we want to log out of our nodes. So on your server, you can't really log out because you can't access it anymore. Yeah, Putty just kicked me out. On your client, just type exit to log out. And then what we're going to do is our final stage, which is finishing up. We're going to delete all of our resources so that they are freed up for other people to use. So if you navigate back to the GENI portal on your slice, down at the bottom in the JAX editor, you can go ahead and click delete, and it's going to ask you, are you sure you want to delete them? And then it's going to go ahead. It might take a few minutes, but it will delete your resources so that they're free for other people to use. There's a general courtesy at the end of every experiment where you're not going to use your resources anymore. Go ahead and make sure you free them up, and certainly have your students free them up if they're using, you have a lot of students using a lot. So that was our experiment workflow. And so we ran through a very simple GENI experiment, and we made slices inside of a project, and we reserved resources from an aggregate. So we went through some terminology, and then used the GENI portal, which was what we first logged into, and then JAX, which was that interface to reserve resources. Does anyone have any questions about the experiment or any other things? Can we delete a slice? I don't believe you can delete slices. Is that correct?
When you remove the resources.
Right, so when you remove the resources, the slice stays. Let's see.
Oh, the slice is deleted when it gets expired.
Yeah, so the slice just is deleted when it expires. So in 6 days, the slice will
Or you
delete.
can change the expiration.
Right, or you can change the expiration. I'm not sure you can shorten it. You can make it expire in a longer amount of time.
Click on one of them.
So let's see. I think that's just, so yeah, because I'm admin, I can go into anyone's slices. So we jumped into someone's slice here.
And you can change the date.
Let's see if we can change it to earlier. No, looks like you can't shorten your slice lifetime. So I think your slices, it looks like your slices expire when they expire, and you can't delete them. Let's see, do we have any other questions in our chat? Looks like no.
Well, thank you all. And we'll make sure to upload whatever we hadn't done before in terms of like the intro slides. Also, feel free to send us any questions you have on email. And we'll send you information for next week's webinar in a few days. Thank you. Bye.